Hello, today we're going to be looking at common acid-base indicators and reference table M, understanding this chart and understanding the different indicators that there are. As you can see on here, guys, we have methyl orange, bromethymol blue, phenolphthalein, litmus paper, brome cresol green, and thymol blue. A couple of things before we start on this reference table to understand is that all of these are liquid indicators. So what you do is you add a drop or two to a solution, and depending on what the pH of the solution is, the solution will change color. So the first one that we see on there on this chart is methyl orange, and methyl orange, you're going to notice a color range of 3.1 to 4.4. On this paper right here, or on this page right here, I've kind of put a shortened pH scale. This pH scale goes up to 14. I could not fit it, so I'm just having it go up to 12 because we'll get the general idea of what's going on once we see what happens. So if I look at methyl orange, what's happening is right around this point right here, 3.1 to about 4.4, this is where we have a color change. Now, if we started off with a color of red, we would be underneath 3.1. So you'd get red right here, you'd get red right here, and you get red right here. That's what's happening with methyl orange. If you go higher than 4.4, you're going to get yellow. And you'll get yellow, 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 and hopefully you get the idea that we're going to get yellow all the way there. So you might be asking yourself, what color would methyl orange be if it was somewhere in that range of 3.1 to 4.4? Well, you guessed it. It's going to wind up being orange. All right. So in that window between 3.1 and 4.4 is where you get shades of orange. You'd wind up with a, deeper, like a bloody orange somewhere around here, and a light orange somewhere around here. So remember that this is a gradual color change that we see. So methyl orange is really useful as an indicator around pHs of 4. Why? Because if it is at a pH of 4, it actually changes color from what it normally is. Bromethymol blue works similar. So I kind of posed a question here about what bromethymol blue would do. We're going to pick a pH, and I'm going to pick a pH of, say, 5. There we go. That's the type of question you get. What color is bromethymol blue, which I'm indicating with BB? You'll see there I'm getting the B and the B from. What color is BB when the pH is 5? Well, here's my given pH. I'm looking at the chart, and the chart says between 6 and 7.6 is going to be my color change. So right in this window is going to be the color change. If we look at 6 and under, we're going to be yellow, 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 yellow. Well, I just answered the question, yellow. If you happen to have a pH that was different, let's say we had a pH that was 8 or greater, you would say this would be blue, that would be blue, that would be blue, that would be blue, and you know it, it's going to be blue down there. So what do you get when you get yellow and blue and you mix them together? Well, you wind up with green. So right in this window, we get shades of green. And you don't have to go to Ireland to know about the 40 shades of green. You can get kind of a deep, rich green. You can get a light green. Just walk out and look at the different people's lawns, and you'll see different colors of grass. They're all considered to be green, but they're shades of green. So that's really what's going on with how to read this reference table. So to get rid of any of my other stuff here, let's get rid of all that. And I did want to talk about two indicators that are on our reference table that do not actually change color. I call these on-off indicators, and these are them right there, phenolphthalein and litmus paper. Basically, I've changed in your notes based on a reality check here. This is what phenolphtalene's cut point is. This is what you get. It's just either it's one color or the other. If you hit a pH of 8 or higher in the real world, it's pink. Anywhere underneath here is going to be colorless. So that's the true story about phenolphthalein. I don't like the fact that the New York State and Merck index, who presented this to you, makes this kind of confusing. They kind of give you an indication as if it would change color. It doesn't. It just flashes to pink once you use this. Phenolphthalein is also a liquid indicator. The other one that we're going to take a look at here, and lastly today, is we're going to be looking at litmus paper. So litmus paper is the only one that is on our chart here that's actually a paper. And what you do is you take the paper and you dip it. You dip it in a liquid to see what's happening. So litmus is the only one that's a paper. And I've given you basically in your notes, this is what we pretty much have here. If you have red litmus paper, what's going to happen is red litmus paper will only change when it's up in this area up here. So what you wind up getting is the color blue. Whatever the litmus paper is will be blue when it's higher than 8. If you are lower than 7, it will be red. So you might ask yourself, well, what would red litmus paper do if I dipped it in a pH of 2? It would stay red. The only one that would change would be blue litmus paper. If you stuck blue litmus paper in a pH of 2, well, then the blue litmus paper will change to red. On the contrary, if you were up around here and you stuck red litmus paper in a solution that had a pH of like 10.5, the red would change to blue. The blue would change, well, the blue wouldn't change. The blue would stay blue. Now, the only thing is what does it do if you stick red litmus paper in a pH of 7? Well, this is all I can say. It'll get wet. That's it. Blue will be blue, red will be red. So the red will be red, and the blue will be blue. Okay? So that's what the litmus paper do. That's why I just simply call it wet. Anyhow, I hope that was helpful for you guys in figuring out how to use the indicator chart.